Hi, welcome to nETSETOS. Today in this video, we'll be discussing about painter's partition problem, a very famous question. And trust me, it's a very interesting question. So the question says, given two integers a and b and an array of integers c of size n. Here we need to paint all N boards. That is the part of a board where it has been provided in the form of array. And A is number of painters who will be painting that board. And it will be units of time to paint 1 unit of board. But here we have some constraints which says two painters cannot share a board to paint. That means, let's say we have an array 1, 3, 5, 7, which is a part of board. A board cannot be painted partially by one painter. That is, one painter has to paint 1 unit of that board. Two painters can't do one part of this board. And a painter will only paint contiguous board, which means configuration where painter 1 paint 1 and 3, but not 2 is invalid. That means one painter can paint in continuous. That is, he has to paint continuous part of board. If one painter is painting 1 and 3, then the other painter will be painting 5 and 7. He is not allowed to paint 1 and 5 as it is an alternate. So I am hoping the question is clear to you. Now let's try to solve this question. So we'll go to open board. Here we'll be taking A, let's say the number of painters here. B, first we'll take 1 unit of time, and C as a array. Let's take it random. 10, 20, 30, 40, 50 and 60. Fine. Now what we'll do, we'll be taking the worst case first. Worst case as in, let's say the board is painted just by one painter. So if one painter will paint, we can take sum of the part of board 10 plus 20 plus 30, 60 plus 40, 100, 150, 210, which will be worst case. Now, what will be the best case for it? Best will be when we have minimum time. One painter can easily paint that board. So we can say the maximum part of the board, which is 60. And then we'll be taking the amount of time, the unit of time which he'll be taking, where we'll be taking at first 1. So here the max of array will be 60. So the least value that we need to paint the board will be 60. So for now, we need to calculate the minimum painters for painting this part of board, where we have 10, 20, 30, 40, 50 and 60. So for this, let's try to come up with binary search. So for that, we need to take the lowest value. The lowest value will take the maximum part of board, which is 60, and the high value will be taking the part of board painted by one painter. So which will be sum of all 210. I'll draw it separately, where we have 60 and 210. This is lowest value and this is high value. Now what we'll do, we will take the mid of low and high and we'll check out whether this mid value, if this mid can fix up with this, where we need to take out minimum painters to paint this board. Now the mid will be 60 plus 210 divided by 2, which will be roughly 270 divided by 2, 135. So what I'll do, I'll be taking a function where I'll be assigning this mid value, which will tell us how many painters we require to paint this entire board in B unit of time. B is 1 here. So if I check for F135, so for this 135, I will keep assigning it part of board till the time taken will be less than or equal to this 135. And when I run out of this 135, that is my value will be exceeding this 135, I'll assign that part of board to other painter. So let's see. Here we have 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, 100, 100 plus 50 will be 150, which is greater than 135. So what I'll do, I'll be giving till 100 to one painter and the rest, which is 110, to the next painter. So total we required two painters to paint this. Now what I'll do, I'll take a variable result and will keep this 135 in this, as in 135 amount of time we can accommodate two painters easily. So till here we are sure that from mid to high we can easily accommodate two painters, and two painters can easily work in such amount of time. Now as we want minimum time, what we'll do, so for this we need to go for this part and try to find out whether two painters are enough for this. So we need to minimize the time to paint whole board. So here we'll be checking whether we can go for less than 135 or not. So what I'll do, I'll take high as 134 and low as 60. And here I'll be calculating mid of 60 and 134, which will be 194 divided by 2, 2 nines are 18, 2 sevens are 14, equal to 97. Now what I'll do, I'll be calculating for F97. Till now, we have calculated for F135 and our result will be 135. Now what I did, I have gone for 60 to 134 where mid is 97. So I'll be calculating for 97 and I need to check out whether two painters are enough for this part or not. So here, let's try to check out 10 plus 20, 30 plus 30, 60 are less than 97. 60 plus 40 will be 100, which is greater than 97. So what I'll do, I'll be keeping 60 for one painter. Then 40 plus 50 will be 90. And if I add 60 to 90 will be 150. 150 is exceeding 97. So let's keep one painter for here and 60 for the other painter. So basically we needed three painters to paint this entire board. But here we need just two painters. So this part will not be efficient for us. And our result will be 135 as it is. Now, as this is not efficient, we will check out for this part whether this part can accommodate two painters. So what I'll do, I'll take low as 98 and high as 134. So if I take 98 as low and 134 as high, mid value will be somewhat 98 plus 134 divided by 2, which will be around 232 divided by 2. 2 ones are 2, 2 ones are 2, and 2 6 are 12. So 116. Now we will verify whether 116 can accommodate for two painters or not. Let's check it out. Here we will have 116 as mid. So 10 plus 20, 30 plus 30 will be 60, 60 plus 40 will be 100, 100 plus 50 will be 150, which is exceeding 116. So what we'll do, we'll take this 100 as for one painter, then 50 plus 60, which is 110, and it is smaller than 116. So here, which is 1. So here we need just two painters to paint this entire board. So here our result will be updated to 116. So we can say in 116 unit of time, two painters can paint. As here 116 unit of time can paint easily, let's try to minimize the time. So what we'll do, we'll be checking for this part where lower will be 98 and higher will be 115. That is mid minus 1. So I'll write here as high, which will be in broader picture from 98 to 115. Now if I calculate mid of 98 and 115 divided by 2, 2 ones are 2 and 2 6 are 12. So mid will be 106. Now we'll be checking for 106. Here we will have mid as 106. So here I'll be checking for 106. Let's check out whether two painters are enough for entire board or not. So let's check it out. 10 plus 20, 30 plus 30, 60. 60 is smaller than 106. 100, 100. 60 plus 40 is 100. So 100 is smaller than 106. Let's try to check out 100 plus 50. 150. 150 is exceeding this 106. So what we'll do, we'll take one painter here and next to the next painter. So 50 and 60, which will be 110. So 110 will be exceeding 106. So we'll be giving 1 to this and 60 to the other painter, where it will be taking three painters. So here three painters are needed to paint this entire part of board. So what we'll do, we will cross this and here we'll be checking from mid plus 1 to this 116, this part of board, which will be in broader picture looking like this. 106 to 115. Low will be 106 and high will be 115. Let's calculate mid of this. Now we'll be checking for function of 110. As up till here 106 was not enough, so our result will be same as 116 as earlier. Now we'll be checking for this part where mid was 110. Now let's check it out whether two painters are enough here or not. So here 10 plus 20, 30 plus 30, 60, 60 plus 40 is 100. Now if I try 50, which will be 150. 150 is exceeding this 110. So I'll keep 1 for this painter 110, 100, and the second will be 50 plus 60, 110, which is equal to 110. That means if I give 1 to this part of board and 1 to this part of board, let's delete this. I can easily say 2 painters are enough for this part. So here my result will be updated to 110. Still, I am more tempting whether I can go for less time. So what I'll do, I'll be taking this low 106 and high as this mid minus 1. That is this part, which in broader picture will be 106 to 109. Now, if I calculate mid of this will be 106 plus 109 divided by 2. So I'll take 107. Try to check whether in 107 two painters are enough or not. So right now I'm checking for this part where mid is 107. I'll delete this as it is making hodgepodge. And here, right now I am checking for 107. So here I'll take 10 plus 20, 30 plus 30, 60, 60 plus 40, which is 100. If I take 50, it will be exceeding this 107. So I'll take from 10 to 40 for one painter, then 50 plus 60. It will be 110. 110 is exceeding this 107. So what I'll do, I'll give one for 50 and second for 60, which in total will be 3 painters. And we just need 2 painters to paint this entire board. So we'll be not able to take 107 and this part fails here. Now we'll be having from 98 to 106. So here we'll be having from 106 to 116, for which mid is 110. This is the minimum time required to paint here. And here from 106 to 110, from 106 to 110, it's failing here. So this is the minimum time 110 is required to paint the entire board with the help of 2 painters. So hopefully you understood this approach of binary search in solving painter partition problem. Now let's go to its implementation. We'll be solving this with the help of Python. So here I'll be going to question, and here we'll take first the start value, which is max of our array, which is C, and value will be taking sum of C. Here, as we are applying for binary search, we'll be going for start should be smaller than equal to and here we'll be taking mid first. Mid can be calculated with start plus and divided by 2, and here we'll be taking the variable as painter. Let's initialize it with 1. We'll take board as 0, and here we'll be painting. So here I'll take the other variable as brush. For brush in C, and here I'll be checking out for board plus brush is greater than mid. If it is greater than mid, then painter will be incremented by 1 as it will be allotted to another painter, and brush value will be given to board. Else, and then board will be plus brush. Then we'll be checking for if painter is smaller than equal to our array, then end will be mid minus 1, else start will be mid plus 1. And then we'll be returning the amount of time which will be given here, and here it is required, and here the answer is required in the form of modulo this value. Now let's try to run here. So this code works fine. So if you liked it, so hope you understood this question. This is very important question as it is asked in Google coordination and in various companies. So thank you for watching it. Take care. Bye bye.